Welcome everyone to today's ASDWA EPA webinar on power resiliency at water utilities, what states can do. I am Bridget O'Grady with the Association of State Drinking Water Administrators, and I will be facilitating today's discussions. So today we'll hear from two of our colleagues, Lauren Wisniewski of EPA's Water Security Division and Bill Gilday of New York State's Department of Health, as they discuss activities and actions that state drinking water programs can take to help water utilities strengthen their power resiliency. This is especially important given the recent spate of extreme weather events across the country. But before we begin, let's walk through a couple of housekeeping items. Questions. We will hold all questions until the end of the two presentations. If you have a question that you'd like to ask, just type it into the question pane at the bottom of your control panel. Will the presentations be available? Yes, we will post the presentations on the security page of ASDWA's website within the next few days. Is this being recorded? Yes, you will be able to view and hear the presentations at a later date. Again, check ASDWA's security page. So now I'd like to introduce our first presenter, our EPA Water Security Division colleague, Lauren Wisniewski. Lauren has been with WSD for 7 years now. During that time, she's worked on a number of really interesting projects, ranging from coordinating multi-sector workshops with other federal partners such as the FBI, USDA, and the Food and Drug Administration, to supporting the Climate Ready Water Utilities NIDWAC, which is National Drinking Water Advisory Council, working group, and polishing up the key features of an active and effective protective program within the water sector. Most recently, Lauren has been coordinating a series of workshops and hosting webinars for water utilities that look at the water energy nexus. And if that isn't enough, when asked, Lauren does admit to a strong attachment to the color Duke blue. Go Blue Devils. Lauren?
Thank you, Bridget, for that great introduction, and thank you all for this opportunity to talk to you about some of the work that EPA has been doing on increasing power resiliency at water utilities. Over the past 2 years, we've had a series of workshops across the country, 7 in total, and have looked at some of the regional issues and various challenges that water utilities have had with storms such as Superstorm Sandy or ice storms or wildfires in California, and how they've tackled those problems and learned from their mistakes to increase their power resiliency. This fall, EPA will be releasing a power resilience guide for drinking water and wastewater utilities, and these are the 7 topics that we'll be covering in the guide. And I know that the primary audience of today's webinar is state primacy agency, so for each of the sections that I cover, I'm going to give you kind of an overview of some of the information and advice and recommendations that we're providing to utilities, but then also emphasize what particularly states can do, and from the state primacy agency, how you can better leverage the utilities in your state to increase their power resiliency and maybe follow some of the information and lessons learned in this guide. To start out with, what's kind of come across at all of the workshops is just relationships are absolutely critical, and building those relationships at all levels, local, state, and federal level. And so the next couple of slides, I'm going to focus on sort of the local level with the utility, and the local EMAs. But then I want to touch on particularly how you're well positioned as state primacy agencies to help with those relationship buildings. During an emergency involving power outages, the power utilities are going to have their own prioritization list, and that usually has a hierarchy. First, they look at life and safety issues, major transmission lines, substations, and then they get down to restoring power to critical customers. In most jurisdictions, this list is developed by the local emergency management agency, sometimes with input from elected county commissioners and others. But this is one of the critical points that we have for water utilities, is to find out who in your jurisdiction or in the water utilities jurisdiction establishes that list and maintains it, and to make sure that they're on that list so that they can get their power restored as soon as possible after an emergency. Along those lines of building the relationship and the communication, We want to make sure that water utilities can contact their electric utility as well as their local emergency operations center 24/7, ideally to have each other's cell phone numbers in each other's cell phones so that they're recognized contacts and can easily get a hold of each other during an emergency, and also to think about if both the landlines and the cell phone lines go down, are there radios or other ways that they can communicate with their electric provider and local emergency response efforts. One of the issues that have come out in some cases is that the electric utility had the location of the billing address associated with some of the key assets, and so when the water utilities are coordinating with their electric utilities to make sure that the electric utilities understand the physical locations of all of the pumping stations, treatment plants, and all of the critical assets that need power to keep water and wastewater services operational. A great way for water utilities to build their relationships with the electric utilities and to really understand each other's demands and responses during an emergency is to engage in joint training and exercises, to either invite each other to their training, to try and design something collaboratively, but kind of through this process they can learn about their emergency response plans, their competing demands during an emergency, how they can best communicate, and what their sort of joint expectations are. As the water utilities kind of build those relationships with their electric providers, they can engage in conversations about things such as tree trimming, or whether they could bury some of the lines to have express feeds to treatment facilities, or potentially to areas where there's a lot of tree damage and potentially down lines because of that. I'm very excited to have this opportunity to talk to the states, because I think the states really have a great opportunity to help really spearhead the effort to increase the understanding of the importance of the water sector and the prioritization of the water sector during an emergency. A couple of years ago, EPA and ASWA developed this Bridging the Gap coordination between state primacy agencies and state emergency management agencies. That could be a good resource to check out. And some of the recommendations that are highlighted in that, as well as things that also came up with the workshop, is to have the state agencies work together in terms of figuring out how water would be addressed in the state emergency response plan, how they can create sort of that global awareness of the importance of water, and then ideally cycle that down as they go through trainings with the local jurisdictions as well, to kind of create a unified voice of the importance of the water sector. At the state level, joint training and exercises is also a great way to build that understanding of the water sector and the water utilities and their needs. There have been cases in emergencies such as Superstorm Sandy where water utilities were not always prioritized by the local and state emergency response. So any proactive work that you can do in terms of building that understanding and awareness with the state EMAs would be very helpful potentially to your utilities during an emergency. Another thing that some state primacy agencies have done after emergencies is to staff the water desk in the state operations center. And so again, that's another way to make sure that water utilities and their needs are being addressed during an emergency. One of the other topics that we covered in our workshops is the idea of power assessments. And in case anyone here is not familiar with power assessments, a power assessment looks at all of your electrical requirements of your utility, and will figure out what are those absolute critical operations in terms of pumping, treatment, that need to sustain operations. And so once you kind of figure out what those needs are in terms of voltage and a whole bunch of kind of technical electrical information, then you'll have a good sense of what type of generator you need, and you can, one of the things that we've been encouraging utilities to do is to enter that information into EPFAT, which is a U.S. Army Corps of Engineer tool. It's something that FEMA and the states will use during an emergency to figure out generator needs. But then just to kind of emphasize, as you all probably well know, that FEMA is sort of a last resort, that they're only there for declared emergencies and are going to be a couple days out in their response. But as a sort of emergency backup, to have that information into EPFAT can be very helpful for utilities. In terms of generators, there's a number of different considerations that utilities need to keep in mind. The power assessments will inform the sizing. That at large treatment plants, you're pretty much bound to a large stationary generator, but at smaller pumping sites, you might be able to have portable generators and generators that you can store out of harm's way on a trailer and bring in after a storm. Buying a generator and having it on site connected is the only way to ensure, that operations and the power continues nonstop after there's a power outage. But there's certainly options to rent or try and borrow through a WARN or another avenue generators. Transfer switches are kind of the connections that you would use to connect your electrical equipment up to the generators, and without and they're required because if you don't have those, then you could potentially backflow the electricity in the line and electrocute people. And those take a while to install, so you can shave, a day or hours off of your setup time for a generator in an emergency if you get those installed ahead of time. Another consideration is fuel type. Diesel is by far the most common fuel type of generators, but gasoline and propane and natural gas may be also options for your utility. Another option is sort of biofuel generators, and those are generators that could operate on either diesel or natural gas, and provides another layer of resiliency so that if one isn't available during an emergency, you can have access to the other. In terms of generator placement, obviously make sure that it's well above the floodplain, well ventilated, and then another key aspect is maintaining those generators. After Superstorm Sandy, and Bill may talk about this further, about 24 or 48 hours, there are a number of generator failures, and this was because a lot of the generators had not been maintained properly. And so the generators need to be exercised regularly under load to make sure that everything is in working order. Some of the things that we've learned from utilities that you could, share with the utilities in your state and, with the state EOCs or the state emergency management agencies as you kind of collaborate on this effort, is that some utilities found it was actually helpful to go off the grid proactively before the storm. That there are 3 phases of power, and if there's disruptions to one of those phases or flickers, that those could actually damage electrical equipment. So that if there was a pretty good sense that power might be lost, that utilities found they were better off just going off the grid. And as I mentioned previously with the power assessments, that will give you information on what your generator requirements are, and to have those ready so that you can share them with the EOC, even if utilities own their own generators, to have all that information available so that if there are generator failures, that they can share those right away. Another a key lesson that utilities have learned is to have the basic supplies and spare parts on hand, and batteries, surprisingly enough, is the most commonly needed item. But during an emergency, it's going to be really hard to get extra parts for your generators, a full set of filters for your fuel tanks, to make sure you have all that on hand so that you can keep things running when you need to use your generators for, potentially a couple days or longer. There's also the awareness that you need to have a backup plan in case your backup power fails, and this is where having your generator needs in EPFAT, or being part of a WARN, or having a contract with a rental company could really help out to make sure that you can continue operations. Another way of building resiliency is at very large sites, when you instead of installing one extremely large generator, to run 2 in parallel. In this way, even if one of the generators fails or needs to be taken out of operation for maintenance, you can still keep operations running. You may have to switch things around a little bit, but at least you have some power that's able to keep operations going and the water flowing. Fuel storage is another critical area, particularly if you're looking at a multi-day outage, and this is where with tank sizing, utilities need to think about, how many days do they want to be able to run their generators without refueling. and think about the various locations, and will they have the ability to move fuel from one location to another. And these are all challenges that, especially after a storm where there's potentially debris on the road, or your main fuel provider may be without power themselves. And so it's worth checking, do they have generators? Do they have the ability to continue to pump fuel if they don't have power? And if not, do you have a plan B or C in terms of getting additional fuel? Another big item is fuel management, that you can't just have fuel sit in there forever and have it still be good. So to make sure that every few years you clean the fuel tanks, you add gel and fuel additives to take away any biological activities, and fuel polishing units can either sit at each fuel tank or be rotated among multiple tanks. And then a key thing, of course, is to refill the tanks. You may have a great fuel plan, but if your tanks are half empty when the storm arrives, then you only have half as much fuel as you were accounting for. So to make sure that you have a fairly aggressive plan to make sure that your fuel is refilled regularly. Moving fuel is also a big issue. That some water utilities have found that some of their vendors were not able to show up with their trucks as planned, and in some cases utilities have found it just easier to either get one large tanker truck, go through the hazmat licensing and placard process, or to in this case the truck shown is a utility vehicle that has a 100-gallon tank, and that falls below the threshold for hazmat, and so they can move fuel around between locations and between their storage site and all of their pumping stations as needed. Another consideration for utilities is to minimize their energy use when using utilities. There was a utility in New Jersey that during Superstorm Sandy was able to take the entire plant off of the membrane filtration and switch to gravity filtration, and that reduced their fuel requirements by 2/3, from 120,000 gallons a day to only 40,000 gallons a day. So that there's options that you can think about ahead of time in terms of maximizing the use of the fuel that you do have on hand. And so in terms of states and your role with the utilities, I think this is just information that you can share with them as you engage with them with training and exercises, to make sure that they're aware of some of the challenges with both generators and fuel, to make sure that they know their power requirements and that you understand them, and that you're really working as much as collaboratively as possible with the electric sector, the local emergency management agencies, and the state emergency management agency, because particularly in a large-scale disaster, the more everyone can be on the same page with the same understanding with the water sector, the better off everyone is going to be. Energy efficiency is sort of is related to this, because the more energy efficient water utilities are, the less backup power they would need, either through how much fuel they would need to run their plant, or potentially if they were more energy efficient, they could have smaller generators that they would need. So one of the things that we encourage is for water utilities to set up energy efficiency audits with their electric providers, and sometimes the state governments can get involved in that and help fund that. And some of the things are variable frequency drives, both for drinking water and wastewater utility, screw pumps in the aeration system, even potentially updating their HVAC and lighting system. There's lots of ways that water utilities can reduce their energy footprint. On-site power is another potential way to help, not completely solve the backup power needs, but potentially help that. Wastewater utilities, of course, have an edge with the combined heat and power and using the biogas to produce energy on their own. Other options that both types of utilities can take advantage of are wind turbines, photovoltaic or fuel cells that they could put on some of their land, as well as solar panels. Of course, one of the risks of this is that whatever storm takes out the primary grid power, could potentially also take out the alternative energy source but that's still potentially still available. The Power Resilience Guide also provides some information about EPA's Fed funds and of course the Drinking Water and Clean Water State revolving funds also offer opportunities through some of the FEMA funding. There is the potential to install transfer switches or buy generators with those, and so we encourage whatever work that your utilities as well as the states can do to let states know on what funding streams might be available to fund the power resiliency efforts. And this is just to let you know that this fall EPA will be releasing its Power Resilience Guide. Within this guide, we're going to have a few videos that will kind of go into more detail with some of the projects or some of the topics and checklists that utilities can easily print out to go through generators and various considerations for those. And EPA will be having about a 5-minute water and power resiliency video that would be great to share widely, as that's going to show the importance of power resiliency and the various steps that the water utilities can take to increase their resilience to power outage. Here is my contact information, and then with that, I think I'm going to turn it over to Bill Gilday.
Well, thanks, Lauren. I appreciate that. And don't forget, folks, if you have questions, I know that Lauren was pretty thorough in everything she had to say, but if you have questions, just type them into that question pane, and we will be able to answer them at the end of today's event. So now I'd like to introduce somebody known to many of you. Bill Gilday is the Chief of the Operations Section in the Bureau of Water Supply Protection and has been with the New York Department of Health's Drinking Water Program for many years. In fact, he has calculated, he is an engineer after all, that if he combines his Department of Health work with earlier efforts in the state's DEQ, he has accumulated a total of 35 years of experience in water supply, contaminated site remediation, environmental remediation, and laboratory analysis. And as a quick note, Bill is no slouch when it comes to the great outdoors. He told me that when he was 19, he bicycled more than 2,000 miles, covering 4 of the New England states and the Canadian maritime provinces of Newfoundland, Nova Scotia, Prince Edward Island, and New Brunswick. Bill also tells me that he hopes to do even more cycling once he retires. And all I can say to that is, whew. Bill, are you ready to talk with us?
Absolutely. Thank you for that wonderful introduction. Appreciate it. Lauren, nice job. Appreciate some of your slides. I'm glad they're going to be available. I'm going to use some of those on generators. Okay, so let me see why. Okay, there we go. Yeah, so we're going to talk a little bit about what New York has done and is doing in terms of power resiliency with water systems. And just a quick overview here. A couple of the things that I like to point out when I'm talking to operators or design engineers is that proper planning is good prevention, and design and construction, good prevention, not so much against disasters, because they will happen. We can't avert storms, we can't prevent disasters from happening, but we can minimize with proper planning the consequences of those things. And I like to highlight that design standards are your friend, because there's a lot of good things in design standards that aren't just for normal operations, but actually have some resiliency built into those, and we'll see some of that. And what I tell to my fellow regulators, and when I'm working with our local health departments that implement a lot of our regulatory water programs, I say that, hey, carrots are better than sticks. If you can hold out some funding, some financing, as Lauren mentioned on her slide, one of her last slides, that's a good thing. And we've been very successful with our state drinking water revolving fund in New York State with just very successful at making several $billion of projects available since it started in '96. And And a lot of the designs that we do within that, we make sure that resiliency is built in. And it's great when you're holding out the financing options with the water systems. And also, I'll share some examples from some involvements of disasters that we've had. Our sanitary code is kind of what spells it out. When we're the primacy agency, a lot of the EPA, we have to have their regs are incorporated into our standards, so they're enforceable. We implement that in New York State. Two of the things, perhaps the two greatest things with respect to emergency planning and preparedness and even resiliency, even with power, we have a requirement for vulnerability assessments and emergency response plans. And we also have a requirement that recommended standards for waterworks be followed during water system improvement projects. The first one, emergency response plans, vulnerability assessments, we have been doing those since 1990, requiring larger systems to do those. And it's an all hazards approach. They have to look at their vulnerability to drought, flood, wind, ice, snow, earthquake, and power loss. I've highlighted power loss because this is about resiliency and power resiliency in particular. After 9/11, there was our public health law was actually amended to shore up those that process and strengthen it a bit by including vulnerability assessments. So, vulnerability analysis was there, but it also added terrorist attack, vulnerability to terrorist attack. And that was something that EPA was focusing on at the time. And we also made it a requirement for all systems serving greater than 3,300 persons. And that's about 350 systems in New York State. I think it's a bit less now because we've had some consolidations, which is another good thing if you can get systems to consolidate towards resiliency. And some standardization in terms of the content of the emergency response plan, what needs to be in there. It also requires a 5-year review and approval cycle. So at a minimum, every 5 years, water systems in that category have to be checking out redoing their vulnerability assessment, or at least checking it out, and also their ERP. And annually, they have to update their contact information. Now, the other aspect of our sanitary code and how it's good for resiliency is that whenever there's a water project, an improvements project, we are called out. It spells out that we have to approve them, the state health department, or working with our local health departments. And it holds out that the recommended standards for waterworks, more often known as the 10-state standards, these are the design standards. These are the basis for our plan review and approval. And we all know that, hopefully we all know, but I know a lot of the states use recommended standards, not just the 10 states, but many of us use it. And redundancy is a big thing. And redundancy in terms of infrastructure for water, everyone knows, okay, sources and wells, it's important. Filters, you got to have redundant filters. Definitely disinfection, your chlorination equipment, got to have redundancy, backups on hand for that. But power supply is also in there. For example, generators can be redundant power source. I got to have a redundant power supply. That's in 10-state standards. Pumps, of course, and interconnections, not so much emphasized in 10 states, but we encourage that in our program wherever you can. Interconnections, interconnections, interconnections. That's, when all else fails, all your redundancy, all your planning, your design could be the best, but when that fails, hopefully you have a neighboring system that still has good water and they can provide that to you. Just briefly here, and these are, I'm just going to go through these slides quickly, but you'll have them on hand. Bridget mentioned they'll be posted, so you could maybe refer back to these for reference. In 10-state standards, there's a requirement overall, a dedicated standby power shall be required so that water may continue to be treated and pumped during power outages. That's something that covers all sections, all projects. That's a generic upfront section 2. Further calls it out for wells, that wells need to have dedicated portable or in-place auxiliary service of adequate support and connectivity. Lauren talked a bit about making sure you have the right transfer switches so you can actually use the thing, especially if it's portable, and it's got to be dedicated. It can't be at the mayor's house or somewhere else when it needs to be at the water system. And we've had those conditions. We've had to make them conditions, especially if we finance them through DWSRF. And of course, pumps, it also calls out for pumps. There needs to be a backup power supply. I'm just going to give you a quick story here, the tale of two power feeds. The city of Poughkeepsie down the Hudson River, about halfway from here upstate down to New York City, they had the benefit of actually two power feeds into their community. They kind of straddled the service areas of Consolidated Edison in New York on the south, and then Central Hudson Gas and Electric to the north. And conveniently, the plant had those two power feeds right into the plant. And they made an argument. They were doing a major plant rehab, and they made an argument. Look, we've got our redundant power sources. We've got two supplies, and we agreed. It was like, okay, they are independent sources, so they embarked on their DWSRF project. And then what happened was kind of unpredicted. We had the great blackout of 2003, and everything went down. Both of those redundant sources were down, and the city had to limp along and do what it could to deal with that for a few days without power and live off their tanks and be creative. So they decided, you know, hey, can we come back in and modify our DWSRF project? And we did the largest change order we'd ever done in DWSRF. We joked that it was $1 million generator. Not exactly that expensive, but it was large. It had a lot of things to power, and they had to do a lot of bank stabilization and ground and site prep work in order to make it happen. So it was expensive. But, yeah, they realized that, hey, you might have two power feeds, but even they can both go down. So they have a large generator. And the 10 state standards for flood protection actually talk about making sure that your electrical controls are not subject to flooding. So that's an important thing to hold out when you're looking at designs and approvals for water systems. And another generic in Section 2, all water supplies have to be protected at least against the 100-year flood or the maximum flood of record. More specifically, under the well section, it talks about the 100-year flood or the highest known flood elevation, actually 3 feet above the 100-year flood. And the same for pump stations, 3 feet above the 100-year flood or 3 feet above the highest flood of record. So here's some wells that are being actually, this was in a project, they're being built out. Obviously the casings are extended quite high because there's a stream back behind the row of trees that floods. But of course it does no good if you've got your, well, it does protect your well if your well doesn't flood, but if the level's up to here, you've lost the power because that's not, that doesn't look flood proof. It looks like the new controls that they were putting up, I'm presuming these are new, these look like they're a bit more watertight. So that's a consideration. Alternatively, just have your controls off-site and use a watertight sealed conduit to your wellhead that's mounded up. Now here's something, a flood level, or actually finished floor level, 100 feet above, or 100-year, it's got to be up at the 100-year, protected against the 100-year flood. Wasn't a pump in here, wasn't a well in here, but definitely there's some chlorination, and you can see some power going in here. So yeah, there was power in this facility. Back here is a stream, a nice stream called the Batavia Kill, and this was this SRF project designed to 100-year flood protection. And well, then Hurricane Irene happened, and that stream just was incredible. And here's the building before, here's the building after. Really, the whole thing got swept away. And yeah, so maximum flood of record is a new thing that we're dealing with in places like Irene and after Hurricane or Tropical Storm Lee and Superstorm Sandy. Just these are very, very, very stringent standards, and we're figuring out how to practically deal with those. This is a building that actually is a pump house, so it was built to be 3 feet above the 100-year flood. And it's a good thing because that same event, Hurricane Irene, flooded this whole valley here. And you can see it's not a very attractive design, but it was designed to be 3 feet above the 100-year flood. and it did flood to the level of the building. The first floor, which was just equipment, was down, but their pump and their controls and their generator here, which you can see, here's a closer up of it, survived. And that was proper design, 3 feet above the 100-year flood. That was estimated a 450-year event. There it is again, and you can see afterwards, this was a picture we came a few weeks afterwards, and you still see some of the twigs and debris from the receding floodwaters caught up in the Gabion mesh there. And that system worked. This is about 200 feet away from that building. This was also 3 feet above the 100-year flood. This is a pump house over a caisson well, and sure enough, the water came up just below the doors of that. But everything kicked in there because of that design. It actually functioned. They lost power. Generator kicked in. The community was substantially flooded, but they had drinking water available. This is actually a system I mentioned at my power resiliency. They had actually a good power cable coming, and it was connected. The weatherhead was still there, still holding up, quite resilient onto the roof. The problem was that the roof was detached from the building, and even so, the building was kind of obliterated. So, and this was the backup. This is the backup pump house for the water system. So, even in your backup redundant supplies, you want to make sure that they've got resiliency. Make sure your generators are above flood level for obvious reasons. This is actually a wastewater control building that I thought was cool because it's obviously built up to be above flood level. Flood walls actually work. This is a hospital that had flooded out in 2006 in Binghamton, and they built a flood wall, and the test came. This is a tropical storm Lee, and you can see that the water is actually held back. We'll get a closer view. This is another shot looking from one wing of the hospital. Just barely made it. I don't know what their design was, but I think this was like a 500-year event for the Susquehanna River, and just it held. It actually held. So flood walls can work. And here's another view where you can see the water behind the wall. And brave soul out here saying, I don't know what you're saying. Yeah, no deliveries today, sorry. What's interesting, and I just happened to notice the storm, the runoff here, the leakage, goes into a storm sewer, obviously not directly connected to the river. That wouldn't be good. So that had to be factored into to the planning of those things. Interconnections, we always encourage interconnections. There's my interconnection slide. This one happens to be bidirectional. Normally, purchase is done from the village out to a town water district through a meter, but it can be valved off, and it can go from the town if the village ever had need and the town had surplus through the meter down to the village. And Sandy, again, Superstorm Sandy definitely tested so many systems. We had a number of small water systems in Long Island. In New York City and the greater metro area in Long Island were very hard hit by Superstorm Sandy and the tidal surge and the storm surge. There were about 62 systems that had drinking water advisories. We tracked those things, 59 boil water orders, and some do not drink. Some had some serious damage. The ones, particularly the ones along the shelter island, the barrier island, not the shelter island, the barrier island. But a lot of systems, it was seamless response because they had a testimony to the design standards and actually having built out. They were very well protected, and you know, when they lost power, the generators kicked in, the pumps went on, everything was good, and the vast majority of them had backup power. There were some other issues with particularly some of the smaller systems, and as I mentioned, right along the coast, the barrier island was hard hit. New York City, one of the things we learned out of that, Lauren mentioned gravity. Consider gravity. Gravity is a wonderful thing. You take your water from up in the Catskills and bring it down across the river, and outside the city have a last high point, and by gravity was able to flow through New York City. Pretty much the whole city still had water, still had fire flow during Sandy, even though the city was very hard hit and without power in many, many places. The largest system in Long Island, which is our second largest in the state, Suffolk County Water Authority, they are a groundwater system. They have over 600 wells and over 200 chlorination, combo chlorination pump stations, and a few treatment stations. They've got 55 booster pumps, 43 pressure zones. They've got over 100 generators, but they strategically placed those so that they kicked on at the right times, ran the right pumps that they needed, were able to use the best wells and chlorination systems. The vast majority of that water system still had good water, still had adequate pressures and water available throughout their service area, which is a remarkable testimony to the effectiveness of proper planning. And of course, I have to sneak in a Warren slide. Always got to advertise for Warrens. Warren. The smaller systems were the ones that really got hard hit. This was a place that got flooded out. You can kind of see the well house here, which that's flooded out. And one of our Warren leaders, his system was more in the middle of the island, was pretty good storm-wise. But there he is out in the boat. He found a boat and was pedaling out to meet the operator out there and see what they could do to assess the situation and what they could do from a Warren perspective. What's fascinating after Sandy, as I mentioned, we're looking at flood levels now that we've never looked at before. We've got to consider climate change, projected sea level rise, and we do have a financing program that came out of the Disaster Relief Appropriations Act after Sandy. Storm Mitigation Loan Program is what it's called in New York State. And we have to, a lot of good projects that are strengthening resiliency for water systems. So they got to look at projected sea level in terms of climate change. Also, the 100-year flood, got to look at those, plus 1 or 2 or 3 feet, depending upon a few other sub-criteria. Look at the Sandy high water mark, again, plus a few feet. And the 500-year flood. The Army Corps, working with FEMA, I believe, and NOAA, have come up with these 500-year flood maps, which we've never looked at those before, but we have to start looking at those now and use the most protective. That's the city of Long Beach there, which was hard hit during Sandy, as you can see. And some of the projects with our storm mitigation loan program increased well elevations and the heights of pump stations, but also new and upgraded generators. Even though the generators worked, you could certainly see that there were under several days, up to 7, 8, 9 days of running, you realize which generators are old and on the fritz and need to be replaced. So there's a lot of projects for new and upgraded generators. Diesel, they were almost all diesel, and towards the, several days into that, it was unsure how the diesel fuel was going to be sent to the island to replenish all of those generators. So a lot of the systems, the generators are being converted from diesel fuel to natural gas. Because the 2 main feeds, large pipes under the water into Long Island, natural gas, were both good during Sandy. They survived, there were no issues. But getting the diesel and other fuels, gasoline, across the bridges was a challenge. And some of the natural gas ones, they're also, I was talking to one operator, he's got a conversion kit that he's also purchased with funds from this, so they can go to propane as well and have that option. And then even fine-tuning the strategic placement, you learn where you can better things. And of course, we're doing some interconnections, and some small systems are being consolidated, including the one with the boat floater up there. They're actually looking at considering a consolidation into a neighboring, much larger system. Just real quickly here, Irene and Lee, we had about 168 systems impacted, 126 BWOs, and a lot of folks that were impacted by that. And I think relative to today's presentation, the greatest cause of the BWOs during Irene and Lee was no power, a loss of power, extended loss of power, and they didn't have backups. Again, that's a lot of small systems. So it all points out that, yep, there's much work to be done still. We'll continue with our VA ERP reviews for the larger, medium, and larger size systems. Continue with water system upgrades wherever we can, holding out the resiliency standards from 10 states for those projects. And whatever funding we can use, DWSRF, Storm Mitigation Loan Program, DWSRF. We have recently enacted a Water Improvement, Infrastructure Improvement Act. Did I mention DWSRF? And then other dollars. FEMA, Lauren mentioned. These are good, always good to have a carrot, you know, when you're asking somebody to do something. It could be expensive. We make these recommendations during sanitary surveys. A lot of our field people do things for resiliency, and occasionally we'll do security inspections, and we make recommendations in that context too. So thanks for your patience. I appreciate it. A lot of slides to get through, and they'll be out there. So if anyone wants to access them or my contact information, it'll be posted. So with that, I will send it back to questions.
All right. Thank you, Bill. I appreciate it. Now let's see what kind of questions we have received. Bill, a question for you is when New York designed the new standards that called for power redundancy or standby power and auxiliary power, did you get any pushback from folks?
Again, I think, yeah, I think that's when, you know, the carrot's a good thing. It's when you're implementing them. Those standards are actually in the recommended standards, which the 10 states, we serve on the committee that does those standards, and we update them every 5 years. And we make sure there's new things that, you know, like resiliency. I'm not sure how long that's been in there. I know it's been in there for at least 12 years in my tenure in doing water reviews. So it's there. It's the standard, and the different agencies that are implementing those, using those, incorporating those into their own codes have, you know, they can point to that. Hey, this is important. And again, with when it's DWSRF, it's really easy to say, look, you know, it's here, just do it, where you got some other funding source. So, yeah, the smaller the system, the more pushback you get. I think we've been through enough events here in New York with snowstorms, ice storms, power outages, the blackout that I referred to in 2003, Irene, Lee, Sandy, that most water systems, they know the benefit of having redundant power. And so I don't know if the committee, you know, what the deliberations were with the 10 states and the province. Ontario sits on that too. But it's a good thing. We don't get too much pushback now.
All right, great. Lauren, I have a question for you that I know you have talked about before, but I think these folks might have an interest in knowing a little bit more about when you were talking about on-site power options. You talked about windmills and fuel cells and solar panels. And do we have a good sense as to whether or not those are eligible add-ons to projects through the DWSRF, or are there other funding sources that we could point utilities to help them if should they decide they want to do solar panels? I don't know where they could find funding for something like that.
I don't know that there is necessarily a funding pot reserved for that, Bridget.
Okay.
If you could I could find out and get back to you.
Yeah, I think that might be helpful if we knew a little bit more. I mean, they're really good ideas, but I think it would also be helpful if we could have the states be ready so that they're not just saying, okay, guys, go out and look at these things, but then not have a way to help them acquire them. You know,
right.
Something they could afford. Right. And I have gotten now 2 questions.
Bridget, could I just offer, Bridget, that in New York State, those types of things are eligible expenses, and I think both with the ERA funding that happened about 6 years ago, and 6 or 7, and the storm mitigation loan program, it specifically encourages the use of green projects wherever you can, either entirely or for some portion of your project. And we consider that part of capacity development because it's going to strengthen the system if they can lessen their needs on outside energy sources.
Thanks, Bill. I think that's pretty helpful, and that's what I was hoping, but I had no confidence that it was really going to turn out to be that way. I like your approach. we have had two different questions talking about operators. One wanted to know if there's any thought being given to having redundancy in operators in terms of we can train the operators in all of the different aspects, and Bill has practical experience in what happens when their treatment plants are overrun. But is there any thought being given to backup operators? Or are there training requirements for operators on resiliency and or emergency management? And I know that's not technically part of what we're trying to talk about here today, but I didn't know whether either of you had thoughts you might like to share on those topics.
I think it's a great point, especially if you have a designated operator. He or she is human, and could go at any time, or could just leave and go to another job, or as we've had with some struggling systems, just hand over the keys. And so I think it's an important point if you can have backup operators or agreements in place for sharing of operators. I'm not sure, I don't belong to that section in our program, how strong we are in encouraging those things. I think we would. Conceptually, it's obviously a great thing. I'm not sure about the regulatory requirements.
Okay. Lauren, any thoughts from the EPA Water Security Division side? Have you all done any outreach or collaboration with the Sustainable Systems team looking at maybe how to make sure the operators are prepared for all this?
I think not specifically on the resiliency topic, but I think in terms of the utilities own sort of workforce management and operations, that would be something that they would probably address there. And that's something through the WARN, being able to reach out to other utilities during an emergency would be another possibility. But I can follow up with the sustainability group and see how we might want to do that.
Yeah, and as I say, I think I'll recognize this was not the principal thrust of any of the discussions today, but I think it probably is a good idea and something that we need to remember when we talk about sustainability and when we talk about resiliency and when we talk about making sure that the water sector is well connected and collaborative and coordinated with the energy sector. So I think that is definitely a thought worth bearing in mind. And I need to look just one quick second to see if we have any more questions. Hang on. No, I'm not seeing any more questions in the queue. If you all do have questions that you want to have answered, we will do our best to try to include them in the written or the recorded version. But as I'm saying, I'm not seeing anything here now. Any last thoughts from either of our presenters before we conclude today's event? Sorry, they're working on our phones here if you all heard that. At any rate, in that case, I think we can declare victory. I want to thank our friends at the Water Security Division for partnering with ASWA to put this webinar on. We are hopeful that this will be the first in a periodic series of events where we look at issues related to resiliency and emergency preparedness and sustainability, and that we can provide some insight into the state perspective through these web events. So thanks to Lauren, and thank you very much to Bill Gilday, our colleague from New York, to kind of put a practical face on everything that we have been talking about for several months now. So thanks to both of you, and thanks to everyone who joined us for today's event. We had any number of state primacy agency staff from the water security arena, from the capacity development arena, from the operator certification programs. We had a couple of regional folks join us, EPA regional folks, and so I think we have all certainly had an interesting afternoon learning more about what states can do to help support the connections between the water and energy sectors. So with that, I think we should sign off. Thank you all very much, and stay tuned. We will post the materials on our website in the very near future. Thanks, everyone.
Thank you.